Okay, guys, here's Mrs. Bergen with, now we are just going to, I already put up the lessons of lesson 1 through 4. So now I'm going to start on lesson 5 and go to as long as I can, as quickly as I can, so I can just get these out to you and you guys can kind of choose. This is taking a lot longer than I anticipated, so I am sorry about that. My phone charger went down big time and I couldn't do any more. So now I'm going to start this back up. Now we are on lesson 5 and I will turn this around. This is again another favorite of the kids. So this one says decimals and percents are always are two ways of expressing the same number. You can write it as a percent, as a decimal, and you can write a decimal as a percent. So in a percent, the whole is 100. So what is the whole in decimal form? Well, the whole, one whole in decimal form is 1 whole, like this. So guys, with a decimal going to a percent and a percent to a decimal, I always think of it as everything is out of 100. Now we've already talked about 100. When you are talking about 100, that is 2 decimal places away. So keep that in mind because that is actually going to help us 2 decimal places. So if it tells us to change a percent to a decimal, we are actually going to be moving that decimal this way to the left. So you would be moving it this way to the left, and it would just be 1 whole. Now, if it was 1 whole, and you want to change it to a percent, you would be moving it back 2 places. So then it would be 100%. So keep that in mind as well. So that is changing a decimal to a percent to a decimal and a decimal to a percent. So we are now going to come down here. Now it says 42 hundredths, right? 42 hundredths as a percent. Well, over here, this is showing 42 hundredths, which is 42 out of 100, which is also known as 42%. The other thing that you could have also done is change it to a percent by just simply changing a percent, a decimal to a percent. You just move it back 2 places and you would get the same answer of 42%. This one says model 19% and write 19% as a decimal. Well, here they're giving you out of 100, so we only want 19%. So that means we just want 1 whole and then 9 more to be shaded, and that would be 19 out of 100. So therefore, 19 out of 100 is 19 hundredths. Or if you want, you could also change a 19% as a decimal by looking up here. I got to move a percent to a decimal by just moving it to the left 2 places. So if it's 19, I move it to the left 2 places, and that is also showing me 19 hundredths. So that is how you do that one. And now we are just going to go to the back of this. So this one says, use the model to complete the statement. 68 hundredths means blank out of 100. Well, that would be 68 out of 100. So they want to know how many squares are shaded. So you come over here. This is 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66, 67, 68. So how many squares are shaded? There are 68. So what is the percent that is shaded? That would be 68% is shaded. Now they said write these percents as a decimal, but if you go back to the other one, and you find out, okay, 47%, I need to change that to a decimal. If you went back to the front page. Remember I said to move it to the left. So you would start here because that is where your decimal is, and you just move it forward to, and it would be 47 hundredths. Now this one is saying 11%. So again, same thing. Here is your decimal right there, and you are just moving it to the left 2 places. So that would be 11 hundredths is the decimal. Now, this one says write the decimal as a percent. Well, remember when you are going from a decimal to a percent, you are simply going to the right 2 places. So I'm going to go to the right 2 places, and I'm just going to start right here. It's already showing me. So I'm going to go 1 and 2, and now it will be 20%. Now this one, I'm going to go 2 places, and it will be 39%. This one, 2 places, that would be 44%. This one, 2 places, would be 93%. Then this one, 2 places, would be 7%. Then again, 2 places. Now here, this is a little tricky, but not much. Remember, there is nothing here, so make sure you put a placeholder in for it, and it is 70%. This one, 2 places, so 1 and 2, and that would be 6%. Then 2 places again, 1 and 2. Remember, you need to put a 0 as a placeholder, and it is saying 60%. So that is how you do those ones. Now, saying put the 12% as a decimal. So remember, if this is a percent, you are just simply going to start here and work to the left. So we are going to go to the left 2 places, and it is the same as saying 12 hundredths. So again, here's another one. I'm going to go to the left 2 places, and that is 31 hundredths. This one, I'm going to go to the left 2 places, and that is 0 and 99 hundredths. Then this one, 2 places, that would be 13 hundredths. And this one, now here's this. I have to still move it 2 places. So there is nothing here. So I need it as a placeholder and a placeholder. So that would be 4 hundredths. So 0 and 4 hundredths. Then again, I'm going to move this one in 2 places. That would be 14 hundredths. And this one, I'm going to move it in 2 places. That would be 90 hundredths. Or you could have also taken that off and said 9/10. Either way, same thing. Next, I'm going to do the same thing here. I'm going to move it 2 places. And that is, again, 9 hundredths. So it looks like it might be the same, but it is not. So make sure you are always doing it 2 places. If there is nothing there, make sure you put in a placeholder so you don't mess up. All right, so this one says, in basketball, Linda made 56 hundredths of her shots. What percent of her shots did she miss? So she made 56 hundredths. Well, they want us to do a percent. So we can simply just change this to a percent so it's easier for us to remember. Now remember, if we have a decimal, to move it to a percent, we're gonna move it to the right 2 places. So I'm gonna do that here. 1 and 2, so that would be 56% was made, but they want to know how much did she miss. Well, remember, all percents are out of 100, so in order to find out what she missed, we are going to simply subtract this. So 0 minus 6, you cannot do that, so I'm going to come over to this 10. I'm going to make it a 9 now. This is going to be a 10. 10 minus 6 is 4, and 9 minus 5 is 4. So this is going to be 44% was missed. Okay, so that's all you have to do on that one. That one is pretty simple. This next one is also pretty simple if you're paying attention. So make sure you are just watching this. It says every percent in decimal can be written as a fraction. All fractions can be written as decimals and percents. For example, 2/5 of a song, songs of Bonnie's music collection are country songs. what percent of her music is country songs. Now, there's two ways to go about doing this. First of all, you all should know that you could put in your calculator 2 divided by 5, and it's going to give you a decimal, and then you can just move it into a percent. Or this is another way that they are showing you, and this is a way that I know that they will be doing over at in 6th grade. So you want to change this out of 100 because none of the percents are out of 5. They're all out of 100. So what you need to do is you need to say, okay, I need to figure out what this is. Now, in order to do this, you would say, what times 5 is going to give me 100? Now, you could sit over here and do how many 5s go into 100 over here and divide it out. Or you could just, some of you may already know it's 20 times 5. So if I times this one by 20 to get 100, I have to do the same to the top. I have to times this by 20. So what is 20 times 4? 20 times 2 is 40. So now it is 40 out of 100, which is also known as 40%. So when you are doing this, make sure that you are changing them out of 100 because that's what it's supposed to do. They're also saying that you can do this as a decimal. Again, you would change this, the 25 over 100, and then write that as a decimal. So that's what they did here. They times each one by 4 to get 25 times 4 will give you 100. So you had to times this one by 4, and that would be 32 over 100. But then they said, what is the decimal, not the percent? So that is 32 hundredths. And then this one is saying write 90% as a fraction to simplest form. So it is 90 over 100, which each one can go into 10 evenly and be reduced down to 9/10. So that is another thing that you could do as well. So this is one that I will let you use your calculator as well. It is here to really help you. If you're not quite understanding it, you could always find it that way as well. So this one right here is saying, what factor would you multiply the denominator and numerator by? 20 times what will give you 100? Well, we just did that. 20 times 5 will equal 100. So this should be a 5. And this one should be a 5. So if you do 7 times 5, that is 35. So what is the equivalent fraction with the denominator of 100? That would be 35 over 100. But then they're saying, what percent is equivalent to that? Well, that is 35 out of 100 is 35%. So now it's saying, this one says, write whatever it is as either a decimal, a percent, or a simplified fraction. So this one is saying 1/4 as a decimal. Well, we already talked about 1/4 in the previous lessons. It was 1/4. 1/4 is 25 cents. So that is 25 hundredths. The next one, you could, you could do 3/10, and we want to change it to 100. So you would do times 10 times 10, that would be 30. 30 over 100 is what percent? That would be 30%. The other thing that you could have done is you could have gone over here and you would have done 3 divided by 10, which comes out to be 0 and 3/10. So that is the decimal. And remember, when you are changing a decimal to a percent, you need to go this way twice, and you're still going to get your 30%. That is just another way to do that. Next, 80% as a fraction. Well, guys, 80% is also known as 80 over 100. Well, here's the next thing. What can go into both 80 and 100? Well, there are several numbers, but the biggest number is 20. So how many 20s go into 80? That would be 4. How many 20s can go into 100? That would be 5. And that then ends at 4/5. All right, the next one is talking about a half as a percent. Well, half as a percent is actually pretty easy. It is 50, remember, like 50 cents, but is what a half would be. But if you want to change it to a decimal, you would move it over 2 places, so that would be 50%. The next one, 9/10. Again, you could go ahead and say, but they say as a decimal. The one nice thing is that this is tenths, and we do have a tenths place. So the tenths place, it's telling you in the tenths should be a 9. So this is showing 9/10. Next, you could have simply times these both by 5 so that it would be out of 100. So I'm going to times that by 5 and this by 5, and that would now be 100. This one would be 55. So what percent would be this? It would be 55%. Or you could have easily on that one went over and divided. I'll just show you real quick. 11 divided by 20 is 0.55, and then you would move it 2 places to the right to make it a percent, which is just 55%. This one, 75% as a fraction, well, we have done this before as well. 75% is also known as 3/4, so 3/4, and that would have been your answer on that. This next one is 3/5 as a percent. Well, guys, again, 3 divided by 5, you could just simply put that in, and it is 0.6. But this is not a percent. So now you got to change this to a percent by moving it to the right 2 places, and it is now telling you that is 60%. Next, you want this as a decimal. Again, you could simply times these both by 4, because that would be the bottom, and you could do it that way. Or you can just simply use your calculator to get used to using a calculator. 9 divided by 25, and that's already going to be in decimal format, which is 36/100. Next, it wants this as a percent. Now what you could do is to get 50 to 100, you would times it by 2 and do the same to the top. Or you could simply go ahead and just divide this out as well. 0, and that would be 58/100. But that is a decimal, not a percent. So if I want to change that to a percent, I move it to the right 2 places, and that is now 58%. Next, 1/20 as a percent. So 1 divided by 20 as a percent is going to give me 5/100, which is not a percent. So I'm going to move it to the 2 decimal places, which would be 5%. Next would be 4% as a fraction. Well, 4% is saying 4/100. And actually, the number that can go into both 4 and 100 is actually 4, and they'll go over more of this when you're simplifying next year. How many 4s go into 4? That would be 1. How many 4s go into 100? That is 25. So therefore, your answer would have been 1/25. The next thing, it would be 4/5 as a percent. Again, 4/5. 4 divided by 5 is 0 and 8/10, which they said it's a percent. This is a decimal. So remember, you got to move it 2 places to the right. And it is now telling you it is 80%. Next, here you could either times this both by 4 to get that, or you could just simply put it in. Again, 24 divided by 25, and your decimal is 0 and 96/100. Next, you could change this to a percent. Remember, percents are always out of 100. So you could times both the top and the bottom by 2 to get it to 100, and then you would know what the percent is. Or you could just simply put it in. 41 divided by 50 is 82 hundredths. However, that is not a percent, that is a decimal. So in order to change it, you would move it 2 places to the right, and it is telling you it is 82%. So that is what else you could have done. Next, it tells you that Whitney has finished 9/20 of her book. What percent of the book does Whitney still need to read? So if you did do this, you could have figured out what 9/20 is as a percent, because they want this as a percent. So 9/20 is 45 hundredths, which is also, if you move it, it would be 45% is what she has finished. But it's saying how much does she still need to do? So therefore, you should take it out of 100, because that's what all percents are out of, and subtract off what she did finish. And so 0 minus 5, you can't do that. So I'm going to come over here. That's going to be 9. This is going to be 10. That would be 5. And 9 minus 4 is 5. So 55% is still needed. So that is that one. And the next one, it says Roger has completed 4/25 of his math homework. What percent of the math homework does he still need to do? So again, you could do the same thing. You got to figure out what 4/25 is. We could also, again, it says percent. So we could change it to out of 100, and you can times this one by 4 and this one by 4. And that would be 16 out of 100, which is 16% is all he did of his math homework. Not a good boy, Roger. But how much does he still need to do? Well, you would have to take it out of 100 and subtract off what he did do. And so you would go 0 minus 6. You can't do that, so you come over here. That would be a 9. And 10 minus 6 is 4. 9 minus 1 is 8. So 84% is still needed. So that is how you do that. So if you choose to try these on your own, you are only going to do this page, lesson 5, and lesson 6. Or if you only want to do one of these, that is totally up to you. Again, I need a total of 10. So however you want to go about figuring out how to choose all 10, but that is the only 2 pages I want you to do if you are doing either lesson 5 or lesson 6 or both of them. You would just be doing these parts on your own and trying it out. So now that that one is done, I am now going to go on to lesson 7, which is talking about dividing fractions by a whole number. And we actually did this before. And so this is just a model, which we have done as well. So what you are going to be doing is it's saying first, you're taking 2/3. And what they did is they took this and divided it into thirds, and then they shaded 2 out of the 3. And then they said, now you're going to take this 2/3 and you're going to divide it 4 ways. So that is what we did here. And you're only going to be shading in one of those 4. So where they come in contact only, overlapping both, is right here. So it would actually be 2 out of how many total should be 12 if you counted up all of these paces. So it would be 2/12 is your answer. Now you could have also said, you could also double check this by doing 2/3 divided by 4. Remember, you should have 4/1. Remember, when you're dividing, it is keep, change, flip. So keep this one, change it to a multiplication, and flip 1 to 1/4, and if you go across, it would be 2/12, which is exactly what we had. So that is what you could have done as well. So that is this one. And next, I have this next one here. Okay. All right, so that is how we are going to be doing this one. I had a whole bunch of papers, and I'm trying to find them, of ones that I already did, and I can't seem to find it. It's all right, I got all the rest of them. This one is a pretty easy one, so I guess I'm gonna have to do without it. So we'll just keep on going here. This next one is saying 3/4. So you're gonna make a square and you're gonna cut it up into 4. So remember that is 3 lines. And then you're just gonna shade 3 out of the 4. So that's what they did. And then they said, now you're gonna cut it in half, into 2. So I'm gonna cut it into 2 and only shade 1 of the 2. So what is overlapping with both of them? Only this darker shading section. And that would be 3 out of, that would be 4, and another 4 is 8. So that would be 3/8. So that would be the answer to that. So next one, now that I have this, I am actually going to use my highlighter, because just like in class, I think it's a lot easier to see a highlighter. So this one is saying that we are going to have 5/6. So that means that we need to cut this into 6. Now, how would I do that? Well, first you could just make thirds like that, and then cut each third in half. So now you have 6 pieces, and of these 6, how many are supposed to be shaded? It says 5 out of the 6. So I'm going to shade 5 out of these 6. 1, 2, 3, 4, and 5. So this is all shaded. Now it says, now cut, and now divide this into 2. So now I'm going to cut this into 2 and only shade in 1 of those 2. So what is overlapping with my orange and my pen? It is 1, 2, 3, 4, 5. So that would be only 5 out of a total of 12 squares. So that is 5/12. Next, this one is saying to cut this into 4ths. So how would you do that? You would just cut it in half, and then another one into half, or just 3 lines, however you want to look at it. And now it says shade in 3. So I'm going to shade in 3 out of the 4. And now it says, and then you're going to divide it into thirds. So that means going into thirds, that means 3 rows. And now only shade in 1 of these 3 rows. So that would now mean 1, 2, and only 3 out of a total of 12 actually were overlapping. So, and that, oh, it says simplest form. So I'm sorry, I forgot about that. You're going to divide each one by 3, and that would be 1/4 is the simplified fraction. Now, again, I am not going to mark it wrong if you did not do the simplifying right as of yet. That is something for 6th grade. They'll be teaching you more about that, but I am not going to ding you on that if you did not do that correctly. 2/3. So in 2/3, that just means you're going to cut up into thirds. So that would be 2 lines. And how many of them need to be shaded? They're saying 2 out of the 3. So 2 out of the 3 are shaded. And then they said, then you're going to take these 2/3 and cut it 3 ways. So I'm going to do into thirds, and then I'm only going to shade 1 of the 3. Again, if I would have flipped this around, it would have said 1/3. So that is why I'm doing 1 out of the 3. And how much is overlapping? That is 2 out of a total of 9 boxes. So that would be 2/9. Next, this one is saying you're going to put it into fifths. So that means 4 lines, 1, 2, 3, and 4. And how many of them are shaded? 3 of them need to be shaded. So there's the 3, and then it says you're going to cut it in half, or cut it into 2 pieces. Or in other words, if I keep change and flip, I would be coloring in 1 out of the 2. So that is why I am doing this. And what is being overlapped is just right here, because it has both my pen and the highlighter in it. So that would be a total of 3 out of how many total boxes? That is 10, so 3/10. Next, this one is out of fifths, so that would be again 4 lines. And how many need to be shaded? That is 2. So I'm going to shade in 2 out of those 5. And then it says, then you are going to cut it into 2, or again, if you put it times a half. So now I'm cutting it in half, and I'm only going to shade 1 of the 2. So what is overlapping is right here. So that would be a total of 2/10, which could be reduced by 2 to both the top and the bottom, and that would be 1/5 is what it comes out to be. Next, this one says it's going to be an 1/8. Now, if it's an 1/8, remember you have to write in 1 less of these lines, so that would be 7 total lines. So just do your best. It's not going to come out to be perfect by any means, not even mine. So 1, 2, 3, 4, 5, 6, 7 lines. So of those 1/8, 5 of them need to be shaded. So 1, 2, 3, 4, and 5. So all 5 of those need to be shaded. And then it says, then we are going to be cutting them up into thirds. So cut up into thirds, and I'm going to shade 1 of the 3. So if I do that, that's what it looks like. 1, 2, 3, 4, 5 of them are being are overlapping out of a total of, if you went and counted, it would have been of 24. So 5/24. This one, it says to go ahead and make your own. All you're just going to do is just make a box. And now this one is saying that you're going to make it into 9ths. So that would be 8 of these. 1, 2, 3, 4, 5, 6, 7, 8 lines. And then 4 of these need to be shaded. So 1, 2, 3, and 4. And then it says, then you're going to cut it into halves. So if you cut it into half and you shade just the top part, so that would be 1, 2, 3, and 4. So that would be 4 out of a total of 18. Which, can that be reduced down? Yes, by 2. So how many 2's go into 4? That would be 2. How many 2's can go into 18? That would be 9. So that would be 2/9. And then this one is saying it again. This is into fifths. So that means only 4 of these. 1, 2, 3, and 4. How many of those need to be shaded? It says 4 out of the 5. 1, 2, 3, and 4. And then we are going to cut it into thirds. So 1 and 2. And then you are going to shade in 1 of the 3. So 1, 2, 3, 4 are overlapping. of the 15, and that is in simplified form. So it is 4/15 on that one. Now this one says Heather, Jocelyn, and Dane are each swimming one leg of a 9/10 of a mile race. They will divide the distance equally. How much will each team member swim? So that is 9/10 is this entire race. And they are going to be dividing it amongst how many people? That is 3 people. So if you want to do this, you could have just have done keep, change, and then flip. So you would have kept this, you would have changed it to a times, and then you would have flipped this around. Remember, it is 3/1, so if you flip it around, it would be 1/3. And if you go across, that would be 9/30. And what can go into both of these? 3 could go into both of these. So that would be 3 goes into 9 3 times. And how many 3s go into 30? That would be 10. So it would be, each one would get 3/10 of a mile per person. So that is how you do that. If you like that, then okay. This one is definitely probably the most favorite out of all of these. So if there's any lessons that you're probably going to do, this is probably going to be one of them. So it says Max sells bouquets of roses. There are 3 yellow roses and 2 red roses. What is the ratio of yellow to red? So this is what you're going to do. It says a ratio is expressed by comparing one part to another, such as 4 feet will have 20 toes. So 4 feet to 20 toes. Or in this case, 3 yellow roses to how many red roses? They had 2 red roses. So when you are doing this, you are going to set up as a ratio. Now there's 3 different ways to set up a ratio. You could set up a ratio as 3:2. That is the correct way. Or you could do 3:2, or you would do 3/2. So it's either one of these ways. Well, when I'm doing ratios, I generally use the colon. So in this case, you got to really pay attention to what is being asked first. It said yellow to red. So the one that was being said first was the yellow. So you need to make sure you say that number first, which is a 3, and then colon and 2, or 3/2, since that one was answered first. So for this example above, you're going to compare part to part. Now you're going to have the ratio and compare it to part to a whole, or whole to a part. So now it says show a ratio of red counters to the total counters. So over here is that picture. The ones that are red, we're going to count that. There's 1, 2, 3, 4, 5. 5 red counters to the total. So now they're saying, okay, what is the total counters that are over here? Well, this is 5, so 6 and 7. So 7 total counters. So we need to answer it exactly how they said. So they said red first, so we need to put that down. Red was 5, 2, 7. Or if you wrote it as a fraction form, it would be 5/7. Whatever way. I always use it as a colon. Next, this one says you are going to find a ratio of red counters to yellow. So over here is that. So they said, how many red counters are there over here? Well, there's 1, 2, 3, 4. So there are 4 red. And how many yellow counters are there? 1, 2, and 3. So now you are going to do it in that ratio that was asked. It said red first, so you need to write down the red. The red was 4, so you got to list that one first. 2, which you could just have as a colon. Yellow, which is a 3. So your ratio is 4:3. Now this one says squares to circles. So how many squares are there is going to be the first question. Well, if you look over here, there would be 4 and then 2, so that means colon. Now you're going to count the circles, which is 2. So your ratio is 4:2, 4/2, however you want to say that. This one says total squares to dark squares. All right, so total squares, I'm going to first do the total. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 total squares to the dark squares. So just count the dark. 1, 2, 3, 4, 5, 6, 7. So this one would be a 9:7 ratio. This over here is saying you're going to use the drawing over here to answer the ratio. So it's saying dark to light. So we're just worrying about the dark versus the light. So dark first. So 1, 2, 3, 4, 5. So that would be 5 were dark, colon, to light, 1, 2, 3. So that would be 5:3. Next, it says light to dark. Well, now we're just flip-flopping this. So the light was 3, colon, and then the dark was 5. And then this one says light to the total. Well, look here. We already know what the light is. The light is 3. And total, we would just be adding all of these. In other words, it would be 8. Next, now we're going to be looking at the triangles in the circle. So it wants to know the ratio of triangles to circles. So we're going to count all the triangles first. 1, 2, 3, 4, and 5. So 5 triangles, colon, and then now are the circles. 1, 2, 3, and 4. So it would be a 5:4 ratio. Now this one says now dark to light. So now we're going to count all the dark. There are 4 dark shapes to the light, which is 1, 2, 3, 4, and 5. So this one is 4 to 5. And now this one says the total amount of shapes. So that would be 5 plus 4, which is 9. So 9, and then colon, how many circles? That was 4. So this is a 9:4 ratio. Now this one says the weekdays to the weekend days. Well, weekdays is Monday through Friday. So that is 5 days. To the weekend days, which is a Saturday and Sunday. So that would be 2. So that would be a 5:2 ratio. Now this one says weekend days first. That is 2. 2 days in a week. Well, there is 7 total days in a week. So that would be a 2:7 ratio. And then the next one says days in a week, which we've already just talked about that. That is 7 days. To the days in January, which is 31. So it is a 7:31 ratio. Now this one says a ratio of length to width of Gus's driveway is 13 yards to 4 yards. But they said, what is his ratio going to be in feet? Well, we have to change this to feet now. So how many feet are in a yard? Well, they just told you 1 yard has 3 feet. So in order to figure out the feet, we would have to times this one by 3 and this by 3. So 3 times 4 is 12. So this one would be 12 feet. And then this one would be 3 times 3 is 9, and 3 times 1 is 3. So your ratio is 39 feet to 12 feet. So that is how you do those. If you like them both, then you are just going to be doing this page and this page. Again, you're just trying it out and seeing how well you do. Now, this one, people were asking about vowels. People say, oh, vowels are A, E, I, O, U, and then sometimes Y. Just for this reason, we will just keep Y as a consonant so that there is no other issues So we'll all be the same here. It's going to be A-E-I-O-U would be the vowels, and then the rest would be the consonants. So if that's what it says, like here it says consonants, here it says vowels, I just want to make everything the same so that there are no questions about that. So there you go. You can go ahead and try those. So that is 7 and 8. Now we're going to move on to 9 and 10. So I'm going to quickly do this. This again is kind of like set up as a ratio, but these ratios are set up as fractions. So here it says to make brass, you can mix 2 parts zinc to 3 parts copper. So the ratio would be a 2 to 3 ratio. If you have 12 bars of copper and use them all, how many bars of zinc would you need to make brass? So the ratio was a 2 part zinc, so that's where the zinc comes in too, to 3 copper. So the thing is now they said, well, what if there were 12 copper? Then what would be this number? So what you could have done is you could have said, all right, 3 times what? Well, give me my 12. Well, that is 3 times 4. So if you times this by 4, you have to do the same up here. It's only fair and equal. So 2 times 4 is 8. So therefore, you would need 8, a ratio of 8 to 12. So 8 zinc bars to make that brass. Also, it says use equivalent ratios. 6 to 8 is equivalent to 18 over 24. So what you would do is you just put them as fractions. And what you could do here is you could say, all right, 8 times what will give me that 24? And you would say, okay, that is times 3. So then I would have to times the top by 3. So 6 times 3 is 18, which is giving us this. So therefore they are the same. They are equivalent. Now, when they don't come out to be the same, that is when they are not equivalent. So now we are going to do this page. This one says, are the ratios 3/5, 3 to 5, and 12 to 20 equivalent? So they said write both ratios as fractions. Well, fractions would just be 3 over 5 because the 3 was listed first. And since this one, the 12 was listed first, it'd be 12 over 20. So now they're saying, okay, are both ratios in simplest form? Well, no, they're not. Because this one can be reduced down by having 4. 4 can go into both of these. How many 4s can go into 12? That would be 3. And how many 4s will go into 20? That would be 5. So this is another way to look at it. Not only can you multiply, but you could actually divide to see if they come out to be the same thing. And this one came out to be 3/5. So write both ratios in simplest form. There they are. So are they equivalent? Yes, they are. They are the same thing. So that is another way you could do it. But I really like the multiplication method. I think it's a lot faster. So in this case, I am going to use my multiplication factor way to do this. So to get 3 to 6, you would times it by 2, and you would times the top by 2 to make it equal. And now you got to make sure that this comes out to be 2. Is 2 times 1 equal 2? Yes. So therefore, they are equivalent. All right, this one. Now this one says 3 to 7, so 3/7, and then this one would be 12 over 21. Now, what do I do to a 7 to get it to 21? I would times it by 3, and then I would times this one by 3. So now let's see if this is right. Does 3 times 3 equal 12? No, it does not. So therefore, this is not equivalent. All right, so now we're going to do more. Here is some other ones. Now this one has 5 listed first, so we need to put that one first. Over blank over 4. Now what do I do to a 2 to get it to a 4? I would times it by 2. So then I would times this top by 2. So what's 5 times 2? It would be 10. So the missing one is 10. This one is 3/6 over 7 over what? Okay, now what would I do to a 3 to get it to a 7? You're like, you can't multiply that to get to that. And you are right. You cannot multiply something by 3 to get it to 7. So in this case, you actually have to go and reduce it on down. So if I reduced this down, each one could go into 3. So that would now be 1 over 2. So that is a half. So now that it's a half, I can now do something to it. 1 times what will give me 7? Well, you would say 1 times 7 equals 7. And so now if I times this by 7 to make it equal, 7 times 2 would be 14. So the missing number is 14. And that's another way to look at it as well if it's not coming out to be exact. So here is another one. What would you do to a 2 to get it to 6? That would be times by 3. And this one by 3. So 7 times 3 is 21. So that's how you would do that. This one, 14 over 21. And then this one was something over 15. Well, again, what can I do with a 15 to get it to 21? It can't happen. So now I'm going to have to reduce this down. I can reduce this down by breaking it down into sevens. So how many sevens go into 14? That is 2. How many sevens go into 21? That would be 3. Now, can you do something to 3 to get it to a 15? Yes, you can times it by 5. So then you would times the numerator by 5. So 5 times 2 is 10. So the missing number is 10. Next, 6 over 10 would be equal to what over 30? So what do I do to a 10 to get it to 30? I would times it by 3. So then 3 times 6 is 18. So the missing number is 18. Now this one, 8 over 9, and then 40 over what? So what would I do to an 8 to get it to 40? I could times it by 5. So then if I times this one by 5, 9 times 5 is 45. So your missing number is 45. Next one, it's saying 3/5 and then 21 over 35. What would I do to a 5 to get it to 35? You would times it by 7. So I would do the same to the top. What is 3 times 7? That would be 21 over 35. So is that equivalent? Yes, it is. So it is equivalent. Next, 4 over 3, and then 36 over 24. Now you could say, okay, what do I do to a 4 to get it to 36? You could say, well, you could times it by 9. So if I times this one by 9, 9 times 3, does that equal 24? No, it does not. It should be a 27. So therefore, this is not equivalent. Okay, next. This one would be 27 over 72, and then this one would be 9 over 24. Well, here is this. Now, they have this one, right? Now, you could also divide, you know, how many 9s can go into 27, or you could just simply look at the 9 and say, what could I do to a 9 to get it up to this number? I'm going to times it by 3, so I'm going to try and times this one by 3, and hopefully I'll get 72. So then if I times it by 3, 3 times 4 is 12, carry your 1. 3 times 2 is 6, plus 1 is 7. So yes, that came out to be exactly what I wanted. So this is equivalent. Next one, 3 of every 5 pizzas that Midgey's Pizza sells are cheese pizzas. So 3 out of 5 are cheese. So 3 are cheese out of the 5 pizzas. So now they're saying, but Midgie's sold 80 pizzas today. How many of them would be expected to be cheese? So we don't know the cheese, but we do know that there are 80. So you could sit here and divide it out. You could use your calculator. How many 5s go into 80? I do believe it comes out to be 16. So if I did that, 16 times 5, that would be, yep, 80. So then if I times that by 16, then I'm going to times this top by 16. So it's 16 times 3. That would be 18. Carry your 1. 3 plus 1 is 4, so 48. So 48 of them are expected to be cheese. All right, so there's that. Next is 10. Lesson 10. So I'm going to just quickly go over this. Here is what you would do here. It says you know how to rate ratios to compare two quantities. A rate is a ratio that compares two quantities. They have different units of measure. A unit rate is a rate that has 1 unit of its second term. So it says Raphael is shopping at a used book and music store. A sign advertises 4 CDs for $12. What is the unit rate for the cost of just 1 CD? So remember, they paid $12 for how many of them? $12 for 4 of them. Now what a unit rate is just 1 CD. How much did 1 CD cost? That is what it wants. So you see how this is 12 over 4. Well, what you want is a unit rate is always over 1. So you want that to be a 1. So what would you do to a 4 divided by what to get 1? Well, you should have said, okay, I'm going to divide that by 4 and this by 4. Or if you just did 12 divided by 4, you're going to get the same answer as well. So what is 12 divided by 4? It is going to be 3. So therefore, it is $3 for 1 CD. So that is what you're supposed to do there. What if the regular price of the CDs is 5 for $20? What is the unit rate for just 1? So it would be 20 over 5. So what you would do is it would be $20 for 5 CDs. So what you could do is you could have easily have done 20 divided by 5. Or you would say, okay, how could I get this to become a 1? I would have to divide both the top and the bottom by 5. And that would be, how many 5s go into 20? That would be 4. So that would be $4 per 1 CD. So that is what you do. You're just changing that bottom number to a 1, and that is going to be your unit rate just for 1. So here, this one is saying find the speed of 120 miles in 2 hours. So the miles over the hours. Well, how many hours was it? It was 2. So yeah, you could have done 120 over 2, or you could just write this out. That would be 120 divided by 2, which is 60. And then you could also have done 2 divided by what will give you your 1. It would be another 2. So that is another thing that you could have done. So the unit rate of speed is it would have been 60. They're talking about miles up there per 1 hour. So 60 miles per hour. All right, so this one says what is the unit rate for just 1 t-shirt? So it's $5 per 2 t-shirts. So now they're saying, okay, what would just be 1 t-shirt? Well, again, guys, just to make this a lot faster, you could have just easily done 5 divided by 2. And it is telling you it would be like this, but this is not in the money. So make sure you put another 0 at the end. So it'd be $2.50 per one t-shirt. This one says there is going to be 200 words per for 4 minutes. So they want to know what would just be 1 minute. So in order to do this, you would just do 200 divided by 4, and it would be 50 words per minute. Next, this one is saying 150 miles on 10 gallons. So they're just wanting to know what would be 1 gallon. Now, to make this 1, you could just divide by 10 to both of these, or you could have just as simply have done 150 divided by 10, and it would have given you 15. So 15 miles per 1 gallon. Now this one is saying write the unit in just write the rate in just fraction form. So they don't even want the unit rate. It didn't even say they wanted the unit rate. So all you would do here is you would just simply just write it over into a fraction. So that would be 90 words over 2 minutes. This one would be $1.20 for 6 goldfish. Next, this would be 5 cents over 1 page. And that one is already in a unit rate. It's already talking about 1. This one, they're saying find the unit rate. So that would be $208 for 4 tires. So in order to figure out how much money it would be per tire, you would just divide this out. So 208 divided by 4 is $52 per tire. Next, 300 miles per 15 gallons. So what would just be 1 gallon? You would just divide 300 by 15. So 300 divided by 15 is 20 miles for 1 gallon. Next, 240 people over 2 square miles. So what would just be 1 square mile? So that would be 240 divided by 2 would be 120 people per square mile. So this one says an ice skating rink charges $1.50 for 30 minutes. So this is per 30 minutes. Now they said, what is the unit rate per 1 hour? So this is just 30 minutes, and an hour is 60 minutes. So in order to figure out what it is per 1 hour, so that would now be 1 hour. Remember, 30 to get to 60, you would times it by 2. So if you times this by 2, some of you could do that very easily. 150 plus another 150 is going to be $3 per hour. So it is $3 for 1 hour. The next one that we are going to be, so those were 9 and 10. So if you liked 9, you could do this part and try it out, just making it equivalent ratios. If you liked 10, this is what I want you to try on your own, talking about unit rates. Remember, unit rate means just one. So that is what a unit rate is. So that was talking about 9 and 10. So now I am going to quickly talk about 11 and 12. So here is what you do on this. This one is saying you can use the formula D equals R times T. Now D means distance, R represents the rate, and T represents the time. The rate is usually a unit rate comparing distance to time, such as miles per hour. So what word is used in place of rate? Miles per hour is really talking about speed. So if you see the word speed, that really means your rate. What are the given values and what is the unknown? So we're going to be talking about this here. So here's the first one. So you're going to use the formula D equals R times T. So this one says a winner of the automobile race drove 500 miles at an average speed of 150 miles per hour. How long did it take for the winner to finish the race? So it said the speed. Now remember, we talked about that. The speed is the rate. So whenever you see the R in this case, that is going to be, you're going to put in 150 for it. So that is 150. That's going to be that number. And then it said they drove 500 miles. Well, is 500 miles the distance or is that the time? 500 miles is actually talking about distance. So the thing that we don't know is the time. So it is T times 150 will equal 500. Or remember, to get T by itself, you want to do the opposite of timesing by 150, which would be dividing by 150. If you divide this by 150, you have to do the same to this side, which then this cancels out, leaving you with just T. And then you would see how many 150s go into 500. So 500 divided by 150 equals it gives you, yes, 3.333 repeating. So that is actually 3 1/3 hours and minutes. So that would be 3 hours, and the minutes would be like around 33 minutes. So that would be 3 1/3. That is actually a very weird one. You really won't see it come out like that too often, where it's a fraction like that. So we're going to now just look at this next example. It says a race car driver traveled at an average speed, so we're talking about the rate, is 120. So with R in this case, that is 120 and per hour, and he wanted to finish the race in 2 hours. So that is, hours is talking about time. So that is times 2. So they want to know what is the distance here. So you would do 120 times 2. So since we have that calculator right here, we are just going to do that very quickly. And that would be 240 miles is what is missing. So the D is going to equal 240 miles. All right, so same thing here. We're just going to plug in numbers for our formula. So remember, what is the formula? It is going to be D equals R times T. So now we get to read this. A cyclist travels 45 miles in 3 hours. What is the speed? So we don't know the speed. So we don't know the R in this case, but we do know what the D is. The distance is 45 miles and the time was 3 hours. So now we're going to plug that in. We remember it is D equals R times T. The D was 45 equals, we don't know the rate, but we do know the time is 3 hours. So now this one, in order to get R by itself, you have to do the opposite of timesing by 3, which is divide by 3. So if I divide this part by 3, I'm going to divide this end by 3. So if you end up doing that, 45 divided by 3, your answer is 15. So therefore it would be 15 miles per hour is what it is. So that is the speed. Next, it says that the train travels on average speed of 80 miles per hour for 5 hours. How far will that train travel? So here it's D equals R times T. The speed was 80 and how much time? It was 5 hours. So if you sat here and you multiply this, 5 times 0 is 0 and 5 times 8 is 40. So that would be 400 miles. So D equals 400 miles. Next, again, D equals R times T. A horse travels at an average speed of 12 miles per hour. And how long will it take that horse to travel? So we don't know the time, 60 miles. So in order to get T by itself, you would have to do the opposite, which is divide by 12 to both sides. So if you did that, it would be 60 divided by 12, and that came out to be 5. So therefore it would take him, take that horse 5 hours to go 60 miles. All right, so next, you're actually going to still do the same thing. It says a hiker travels at a speed of 3 miles per hour for 3 hours. So in this one, we know the speed is 3 and we know that the time was 3. So therefore, the D is going to be 9 per hour. So it's saying how far will he go? He will go 9 miles. That's the distance. Next, it would be D equals R times T again. The speed is 2 centimeters per minute. So they're actually changing it up a little bit. How long does the snail take to travel 30 centimeters? So in this one, we don't know the time. Again, we would divide each one by 2. So what is half of 30? That would be 15. So our time in this case would be 15 minutes because we were talking about minutes in this case. So you got to be really careful of what they're talking about. This one, it's saying 6 miles, travel 6 miles. So distance equals rate times time. So 6 miles is distance in 24 minutes. So we're going to put the time over here and they want to know what that speed is. So we're going to have to divide by 24 and divide by 24. But that's where this is actually a proper fraction. Yes, it is. But what you would have to do is now just reduce this down. What can go into both 6 and 24? That would be 6. So it would be 1. How many 6s go into 6? That would be 1. How many 6s go into 24? That would be 4. So it would be 1/4 miles per minute. So that's what it does. All right, now this one is just, again, it's just plugging away. You're just plugging it back into the formula. So same formula. So we don't know the R, so it's going to remain an R. This is going to be an 8, and this is going to be 320. Divide each one by 8 to get R by itself. So if you did 320 divided by 8, it would be 40. So your answer would be 40, but you got to be very careful. 40, what are they talking about? Centimeters per, they're talking about time is in seconds. So it'll be 40 centimeters per second. This one, it's saying kilometers per hour. So you got your hour. So the thing that they're missing is your kilometers. So this is going to be kilometers. And then to do this, you would do distance equals R times T. This would be a 6. This would be a 50. So in order to do that, that would be 0. 6 times 5 is 30. So that would be 300 kilometers. Next, this is feet per minute. So what are we missing here? We are missing the minute because we have the feet. So we need the minute here. So now we would do 150 is the distance, the rate times the time. So we don't know the time, but we do know that the rate is 20. So in order to do this, you would divide by 20. So 150 divided by 20 is 7.5 or 7.5. So 7.5 minutes, or other known as 7.5 minutes. So whatever way you want to look at that. Next, in the experiment, Ava found that the ball took 5 seconds to roll down an 80-foot ramp. What is the average speed? So again, distance equals rate times time. In this case, the time was 5 seconds. We don't know the speed, so we don't know the rate, but the distance is 80. So in order to do this, we would divide by 5 to both sides. So that would be 80 divided by 5 is 16. So it'll be 16 feet per second, because that's what they were talking about, seconds and feet. All right, next. Jason's family was driving 1,375 miles to the Grand Canyon. They plan to travel at a speed of 55 miles per hour. How long will it take them to reach the park? So this is distance equals rate times time. We don't know the time, but we do know the rate was 55 miles per hour or 1,375. So you should divide by 55 to both. So now we do 1,375 divided by 55, and that would be 25 hours. So T will equal 25 hours to get there. All right, this next one, number 12, is talking about negative numbers and positive integers. So here it says that you can have a number line to show 0 and the whole numbers. You can also extend the number line to the left of 0 and show the opposites of the whole numbers. For example, the opposite of a positive 3 is a negative 3. Any whole number and its opposite whole number is called an integer. So these are all integers because it is showing its opposite. So negative integers are written with negative signs, and positive integers are written with or without positive signs. So you don't have to put a positive there in front of it if you don't want to, if it is positive. If it is negative, it has to have a negative sign. So A temperature at Fairbanks, Alaska was 37 degrees below zero. So if it is below zero, you need to decide whether this is a positive or negative. The word below means that it is now even colder than zero. So it is actually, tells you that the integer is negative. So write the integer then. It would be negative 37. So the temperature in Fairbanks would be negative 37 degrees. So the koala bears gained 11 yards on a football play. Write an integer to represent the situation, then tell what represents zero in this situation. So in order to do this, to decide what is positive and what is negative, positive integer here represents yards that were gained. And then negative integers would be represent the yards that are lost. So there you go. So what is zero means with yards are neither gained nor are they lost. So nothing was lost and nothing was gained if it's at zero. So that is what you do there. So now it says you're going to write the integer to represent the situation, a loss of $25. The word loss represents that the integer is, well, if you lose something, you're actually minus that. You don't have that anymore. You just lost it. So actually it is negative $25. So the integer that represents that situation is, sorry, I did not read the words. So that means it is a negative. And then this would be a negative $25. So this one says 73 degrees above zero. So we're going above, so that means that is over zero. So that is just either, you could say a positive 73, where you don't even need to have this, but 73 degrees is good enough. Next, it says 200 feet below sea level. So you are going below it. So you are actually going into the negative. So that would be negative 200 feet. Next, a profit. What profit means is you gain that money. You are making money. So a profit of $76 would actually give you $76. Or if you want to put that positive in there, that is fine as well. Next, it says the passenger jet flew an altitude of 34,000 feet. So the jet is up in the air. It is really high up there. It is not below sea level. It is really high. So therefore, that is a positive 34,000, sorry, positive. Or you don't have to put that positive there. What does just zero represent? Zero represents the ground level. This one says Zach lost 45 points on his first turn. So if he lost it, that would actually be a negative 45. So what would zero represent? He would neither gain or lose points. Next, Craig was 20 minutes early for his appointment. Well, when you are early, you are not negative minutes. You're not losing minutes. When you are losing minutes, you are in the negative when you are missing some of it. So say you came in late, then you are now minus 5 minutes off of your appointment. Well, in this case, you're actually early. So that is actually a positive 20 minutes. Why is that? Because you are early by 20 minutes. So what would just zero represent here? You Well, he is on time. He's on time, yeah. So that's all we'll have to say there. Write an integer to represent the situation. The temperature went up 2 degrees. Well, if it goes up 2 degrees, it is either, you could say plus 2 degrees or just 2 degrees. It is 11 feet below sea level. Well, that is below means 11 feet, negative 11 feet. An increase of 37 students. Well, increase means you are adding 37 students. So that is a positive 37 students. Next, 15 seconds before the rocket liftoff. Again, before. Now, this is one that got me. You know, my answer key is saying something. Other people are saying another thing because they always say T minus to liftoff and stuff like that. So, to be honest, I don't want to tell you wrong. This one is a little difficult, but my answer document is saying that it is positive 15 seconds. But this is another one that could be a weird one because they always say T minus to lift off. So you could have said a negative 15. It's just how people look at it. I would think it's like positive. You're not losing any time. So 15 seconds, positive 15 seconds. Next, Amelia earned 1,200 in 1 week. So if she earns that, it means she's gaining that money. What would 0 represent in this case? She wouldn't gain or lose money. Next, the coal was 2 miles below ground level. So that is negative 2 miles. So what would 0 be? Just be at ground level again. The alarm clock rang 5 minutes early. So again, I think it's a positive 5 minutes. You're not losing any time. You're actually ahead by 5 minutes. So therefore, what would 0 represent here? It would go off right on time. All right, next one. Gina withdrew $600 from her checking account to pay her new guitar. What integer can you write to represent the withdrawal? So in order to show the withdrawal, you would have to say withdrawal means you take money out. So you're actually negative $600. So what does just 0 represent? 0 means she doesn't withdraw or deposit any money. So that is how you do that. So that is 11 and 12. So I am going to see here. All right, so it is almost 8:30 right now at night. And I think I'm going to stop right here and I will pick up on lesson 13 tomorrow and I will finish the rest of the 20. So I will get back to you guys tomorrow and I will record the rest and then post it after that. So I will say goodbye to you for now and look back tomorrow to get the rest of the lessons. Thanks. I'll talk to you guys tomorrow. Bye.